Hi, how you doing? My name is Artem Ishkov, and today I'm gonna prove Pythagorean theorem that in a right triangle, two categories, square of first category plus square of the second category equals square of the hypotenuse. And basically on paper it looks something like this: a squared plus b squared equals c squared. And hopefully I'm gonna do a good job of it, so that maybe it can help some of y'all whenever y'all trying to prove it in your class. Maybe it'll make some sense, hopefully, and hopefully it'll help my children that are growing up, and they'll be able to look at it. Alright, there are several ways to actually prove it, and one of them that came straight to my mind is going to be finishing it to a square. Actually taking one triangle, the original triangle, and we'll call the sides traditionally A, B, and C. And then we're going to continue B side and A side in the directions shown on paper, where you can see the arrows. And we're going to finish drawing this. Oh, by the way, we're going to mark the A with one little stripe and B with two little stripes, like you see it over here. And I'm going to explain how they actually connect. So over here on B side, we're going to continue with the A side. Then we're going to make a 90-degree angle, and at that 90-degree angle, we're going to draw the side with a length of B, like this. So now we have two sides and an angle between them. By the rule, we know that two triangles are equal. There are several different rules, but in this case, by two sides and angle in between them. So now if we will connect the third side like this, and excuse my drawing if it's not perfect, if it's not to scale, I'm not, doing it by hand. Then this side, since the triangles are equal, is going to end up being equal C, so we can draw it like that, with the letter C. So by the same method, we're going to continue, and we're going to draw a third triangle with the side A and B, and once again, that triangle is going to be equal to the two of the original ones. Well, to the original one and to the second one, by the same definition of the two sides and an angle in between them. We can draw it like that. Now, your teacher may ask you, okay, so if you draw a third triangle, where is the guarantee that it's going to fit in there? That's what a lot of students usually say. Well, then we'll draw a third triangle, and they kind of skip that step, and they say, well, it fits, and then they go from there. I'm gonna do it a little bit different. We're going to, instead of drawing a triangle in there, we're going to say that we continued. We're gonna point two arrows over there, just like they're pointing over here, this little arrow and this little arrow, and we're gonna continue them until they cross and see what happens. Once we continue them like this, we have a figure with four corners: this corner, this corner, this corner, and this corner. As we know, the inside sum of those angles, by the rules of the, have to be 360 degrees. Well, since there are four of them and three of them are 90 degrees, so it's 90. So we're gonna get 360 degrees minus 90 degrees minus 90 degrees minus 90 degrees. What do we have left? We have 90 degrees. So this angle over here is going to be 90 degrees. So now we have a figure with, let's see, four 90 degrees angles. Hey, that's a square. And as we know in a square, the opposite sides, well, all the sides are equal. So this side is, combined side is A plus B, this side is A plus B, this side is A plus B, and this side is A plus B. But hey, we already have A, which means this leftover piece right here is going to be B. Now on this side, we already have a B, so this leftover is going to be A. So, and then we have two sides and a 90-degree angle. Therefore, if we connect these two dots right here, two sides, angle between, triangle will be equal to the original one. So all four of these triangles will be equal. So we can draw a side C on here. Alright, so now we have a large square, and we're gonna call it that, large square for right now. And we have an inner figure with four sides C. So, hold on. So, next thing that we're going to do is prove that the inner figure, actually I can see it pretty good from here, from that angle, with a side C, we got to prove that it's a square. It would be very helpful in our proof, in today's proof. There are actually several ways, like I said, to prove Pythagoras Theorem, which you can look it up later on. Alright, let's take a look. How can we prove it? Let's call the angle in our triangles across from the side A, angle alpha, and angle across from side B, angle bravo, or beta, or whatever you want to call it, with a letter like this. Across from side A with the Greek letter alpha, and across from side B with the Greek letter beta. Well, the sum of the inside corners in a triangle, as we know, is going to be 180 degrees. So alpha plus beta is going to give you what? 90 degrees. So, let's go ahead and mark all of those angles in all of those triangles real quick. So across from each side B, we're going to mark beta. Across from side A, angle alpha. So we're going to have a whole bunch of alphas and betas. Give me just 1 second over here so I can mark them. And then we're going to look at the sums of those angles. From the first triangle, we know that the sum of beta and alpha equals 90 degrees, because this angle is 90 degrees, and the sum of the angles on the inside of the triangle is 180. 180 minus 90 gives you 90 degrees. So, alpha plus beta equals 90 degrees. But since the triangles are equal, here's how the angles came out to be. Alpha, beta, the sum of the straight line, or basically 180 degrees. Y'all can look up the proper term in your book, or your teacher can tell you. It's escaping me right now, not on top of my head. And I can redo the video later on if y'all really want to, with all the proper terminology. And excuse my Russian for any accent. So we have alpha and beta here, and angle in between. Let's see, alpha and beta gives you 90 degrees. This whole angle with the inside angle gives you 180. 180 minus 90 gives you what? 90. So, but now look at here. Again, alpha and beta. So in between, 90. Again, alpha and beta. Between 90. Same thing here. Alpha and beta in between 90. So we have a figure on the inside with the side C with the four angles that are 90 degrees. Let's go ahead and mark it. So it comes out to be a square with a side C. So it's starting to get interesting. I kind of mark it like that. Maybe my drawing is, you might have to maybe look at it and kind of think about it as you follow. It's not as good as some of you folks can draw really well. It's maybe not as to scale, but I think it's alright, and it explains you everything pretty good. Especially when your teacher runs through it in school, and then you need to sit down and actually look at it and be like, alright, how do we do it? So, here comes the fun part, proving that a square plus b square equals to the c square. Well, the area of the large, I'm going to call it just like that, large figure, is going to be, when I say large figure, the area of the big square on the outside, the whole area, everything on the inside, equals, it's a square, so it's going to equal to the side square, right? The side of this figure, of this square, is b plus a, or a plus b. So the area of the large square equals a plus b in parentheses squared. Whoops. Equals a plus b in parentheses squared. A large equals a plus b squared. Also, it consists of, if we break it down, of 1, 2, 3, 4 triangles, so their combined areas, and area of the inner square. We're gonna write it down just like that. So area large equals to, and area of the inner square has a side c, so it's gonna be c squared plus 4 times area of triangle. So basically I wrote down like this. Area large equals c squared for the inner square plus 4 times area of the triangle, because it's 4 triangles, 1, 2, 3, 4, and they're all equal. Now, we're gonna break down the area of the triangle. 1/2 base times height. So breaking down a large equals to c squared, like we already had, plus 4 times 1/2 times base times height. But in this case, base and height, that's a and b. So 1/2 times a times b. Well, we can reduce 4 and 1/2. It's gonna come out to be 2. And basically, it ends up being equals to c squared plus 2ab. It's fairly standard mathematics, fairly standard algebra. And next thing, since we know that a large equals a plus b squared, and also a large equals to c squared plus ab, I circled it over here. Our top a large equals to a plus b squared, and a large equals to c squared plus 2ab. So we know that from this part equals to that part. Let's go ahead and write our equation. So it's going to look something like this. A plus b squared equals c squared plus 2ab. We're getting closer to what we need. So, let's take a look and open up our parentheses. Well, as we know from standard algebra, a plus b squared equals to a squared plus 2ab plus b squared. And we're going to continue with the c squared plus 2ab. So we simply open up the parentheses at this point. And hey, look, a squared plus 2ab plus b squared equals c squared plus 2ab. But 2ab on this side and 2ab on this side of the equation. So we can subtract 2ab from both sides of the equation. Or cancel it out, or however you want to, whatever proper term you prefer to use over here. We can pretty much say minus 2ab on both sides. So I just strike through it. You can do it proper and literally right on the side, minus 2ab from both sides, however your teacher prefers. So, what do we have left? On the left side, we have a squared plus b squared. And on the right side, we have plus c equals c squared. And in Russian, it would be called ЧТД, что и требовалось доказать. And basically, that's what we were looking for. A squared plus b squared equals to c squared. It's about 14 minutes of explanation. And hopefully, it made pretty good sense to y'all. And if your teacher ever gives you a homework to prove it, or maybe it'll help you to understand it because you want to, and maybe lead you more into mathematics. Alrighty. And my name is Artem Ishkov, and that's one way to prove the Pythagorean theorem. Y'all have a nice day.